Hello folks, I'm doing a series of simple video tutorials for describing the issues with the multi-step analysis, finite element analysis within 3D experiences release 2024x. These are tutorials at this point 1 through 6, and I will be discussing them gradually as we go along. Now, because the ideas can be discussed for any type of element, I'm going to use the break element. I'm going to take a very simple uh, axially loaded member, as shown here. Uh, now, the it, it, the because it's actually loaded, I don't want to clamp the left side because there will be stress concentration here when you pull this thing or push it in. So what I decided to do, I apply minimum number of constraints here so that actually it's not the clamp, but it still allows us to run the problem. And here's the situation. On the right hand side or on the left hand side, this bottom corner is fixed from displacement in 3 direction. Uh, that face is on slider, which means that this can still hinge about that line. To prevent that, I just prevent the motion in the vertical direction of that corner point. Now, the right-hand side is a combination of pressure or displacement, as was mentioned in tutorial 1, and I'll repeat it again. So first of all, it's assumed to be 10 inches long, 1 by 1 cross section, made of steel, with Young modulus given here, and Poisson ratio 0.3. Of course, I can use 0 as a Poisson ratio, but that's okay. We leave it as 0.3. Excuse me. And I'm going to apply. I'm interested in applying a pressure of 3,000 psi at this right face, or the displacement of 0.001 inch at that right face. Now, I'll show you below that actually when you apply a pressure of 3,000 psi, it'll give you that displacement, or if you apply that displacement, it requires that much of a pressure on the face. So the way to convince you, we look at this bar as a fancy spring, essentially. So the displacement of the end of the bar, right end of the bar, is forced over the stiffness of that spring. But we know from elementary strength of material, the stiffness of this fancy spring is AE over L. So just replace K with AE over L, clean it up. And we also know that the force applied is pressure times the area. Therefore, the area cancels, and we get PL over E. Now, if you plug in P3000, L 10 inches, and E is given here, what you get is 0.001 inch. That's why these two are related. Now, we're going to be discussing case 2 because case 1 was already discussed in tutorial 1. I'll mention that in a minute. So what I'm going to do in tutorial 2, which is this tutorial, I'm going to do that in 2 steps. In step 1, I apply a pressure on the right side of the beam to make it go into tension. It stretches basically. And because of what we know from the 3DEXPERIENCE FEA solver slash abacus, essentially, uh, the boundary condition that you apply here, or the load that you apply, is automatically propagated to the next step unless you decide to delete it or modify it. So what happens is that this pressure of 1000 tension is automatically propagated into the next step, step 2, and something that's not intuitive. If you want to put this thing in tension, what I can do, I can say that right face, that right end, a translation of 0 inches is applied to it. Now, this is not intuitive because one probably would think that it should be negative 0.001, but that is not the case. We'll see that if you put negative 0.001, you'll get something that just doesn't make sense. Now, what I've done in tutorial 1 was different in a sense that I applied the pressure just like I did it in I'm doing in tutorial 2, and then this is propagated and then applied a compressive pressure. Compressive pressure means that here the pressure is going to be positive, which means compresses the bar, and this worked fine. So right now tutorial 2 is going to be this approach. However, there will be 3 other approaches that are going to be in tutorial 3, 4, and 5. Okay? Now, notice that here I'm saying that I'm assuming in all these 5 tutorials, I'm assuming that there's a single uh, structure analysis case, because later on I will come back and introduce 2 structure analysis cases, but let's not worry about it right now. Now, what I'm going to do after I show you that everything works fine, then I'm going to say that, okay, what if I go and remove that pressure in uh, step 1? In step 2, I'm sorry, not step 1. What if I go and remove that pressure that was automatically propagated to step 2? Okay. Uh, Now, if we do that, and by the way, and the way, uh, and by the way, what we're going to do is we're going to, if we remove this thing, we'll see that actually it will work fine. Okay, it will work fine. Remember that in the case, in the case that was here, in the case that was here, if we removed it and we removed it and we apply the pressure on the right hand side, compressive pressure, it will not give you the correct values. Okay. Anyway, here in tutorial 2, we're going to remove that uh, pressure 1 that made the thing stretch in static step 1, and we'll see that everything is going to go fine. And these are, of course, what we're going to do later on. Now, what is this business of one structure analysis case? So in tutorial 6, I'm going to do this problem with 2 cases: structure analysis case 1 and structure analysis case 2. And that's going to be tutorial 6 in the playlist that these things are appearing in. Okay, so let's go ahead and do that. So we go here, we start with the part file. There we are. On that vertical plane, I will sketch. I'll sketch a 1 by 1 inch square. Okay, exit and padded by 10. We are 10. Okay, good. Let's apply material to it. So we create a material. I'll call it tutorial 2. Okay, it's created there as a dummy. So I'm going to apply that there, tutorial 2. I'm going to apply it to this. Check the green arrow, green check mark, and we can close that, and we're going to input our values. Okay, so it is structures, abacus multiphysics, mechanical, elasticity. For elastic, we put down 29 million. Oh, sorry, 30 million. 1, 2, 3, 4, 5, 6. Poisson ratio 0.3. Okay, good. Excuse me. Now we're going to go to structural model creation, where we do the meshing. Empty FEM model. Click on the mesh. It's a sweep mesh. Select that. Oops. Cancel. cancel that for a second. Let's try it again. Sweep mesh. Okay, so I don't want it to be swept like that, so let me manually select these things. Okay, let me undo this. Face 1, I want this. I've got to remove these. Okay. The support is this part. Source is, for example, that side, and target is this side. 0.25 inches size, rough size. So on this side, there's going to be 4 of them, 4 and 4, and then there's 20 layers through this. Okay, so same thing that we got before. All right. Now, properties. Click on the solid section. Select the part. Material is properly selected. There we are. We're done here. So now we're going to go to structural scenario creation. And we're going to, it's a structural problem. And then we're going to use the finite element model we created. And say, okay. Okay, notice that as soon as you do that, structural analysis case 1 is created. And in tutorial 1 through 5, this is all we need. In tutorial 6, I will create another one. In the same tree, I'll create another one. But let's not worry about that right now. Okay, so what's the procedure? Procedure is static step. So point 1 and point 1. All right. And let's see, for boundary conditions. Let's apply a restraint at the bottom right corner, left corner here, this point, X, Y, Z, clamp or fixed. And then I'm going to turn this thing around. Another one at this corner, but only Z is fixed. Okay. And then we need a slider surface here, roller surface slider on that face. There. Okay, so that takes care of a left end. Now notice that for this tutorial, in step 1, I apply pressure, making it stretch. So we go to loads, pressure on that face. Because we want it to stretch, put a tensile behavior in that piece. I put a minus 3000 psi. Okay, so that takes care of step 1. Now, I can run it and look at the result, but I want to create our step 2 and then run it at the same time. Okay, so what's the step 2? First of all, this is going to be propagated, automatically propagated. Okay, good. And then I apply a translation of 0 to that face. This is something that's non-intuitive. So let's go ahead here and do another procedure. Static step. This is going to be step 2. You can see that. Point 1 and point 1. Notice that there's going to be a second step created here. All right. And then we say, okay. So the pressure is automatically propagated. Okay. Here's step 1. There was a pressure here. And now that's automatically propagated. Now, if you want to see it a different way, right click feature manager. You can see that there's a step 1, there's a step 2. This is the pressure that I took. This pressure is started step 1 and it is propagated through step 2 automatically. Now, what I want to do is I want to remove this. I'm sorry, not remove. Later on, we're going to remove it. That's for later on. This is fine, no problem. Apply 0 translation to that face. So we're done here. So where is the initial boundary condition? Not initial boundary condition. Apply translation. to that same face. This is not intuitive because in all likelihood, in the y direction, in all likelihood, you say, wait a minute, I have to apply negative, probably negative 0.001. But let's find out. I'll put a 0 here, just like I said there. Apply 0 translation to cause compression. All right. And then we say, okay, good. We're done. So now we go to simulate. First of all, let's go ahead and uh, make it check for model. I don't anticipate any problem. Good. And now we're going to simulate, run it, and it's going to run both cases at the same time. I mean, consecutive. First it'll do case one, and not case one. First it'll do step one, and then it'll do step two. And we're going to check our results, see whether we get 0 at the end of step two. That's what should happen. In principle, you stretched it by applying a pressure, and then you are putting compression into it by applying that translation of magnitude 0, which is not intuitive. I would have liked to say minus 0.001, but at the end of that step, I should get 0 stress. Okay, we'll find out. And then we're going to mess it up. We're going to try to make it wrong. Okay, that's done. Okay, so let's see. I don't want one meter stress. I want the component of stress in the component two of the stress, namely stress in the y direction. So let's go ahead and do it with uh, sigma 2, 2. There it is, tensor component. Say okay. Let's see now. So we go to step one. At the end of step one, we stretch this thing. So there's a tensile stress in it, 3000 psi. We know that. This is the end of step one. Now we go to step two. Beginning of step two, it should be 3000. It is, because that comes from the previous step. And then as we apply that translation, 0 translation, this stress is going to get smaller and smaller and smaller. And eventually at the end of that, at the end of this, it should be 0 or almost 0. 0. We can see that. Good. Very good. Now, let me go back here. Let's screw it up. So first thing I'm going to do is I'm going to say, okay, why don't I in this analysis, remember I said applying 0 translation is not intuitive. You might be more inclined to say, you know what, I'm going to make it negative 0.001. So let's go ahead and try it first before actually I do this. Okay. So I go here back to where is that translation. I'm going to make it negative 0.001 inches and run it and tell you that something's wrong. Simulate it, check exactly what we did a minute ago, and we're going to see that there's something wrong. So this sounds more reasonable. You stretched it, and then you want to kind of push it back. So maybe you're inclined, or I'm inclined to say, okay, let's push it back by the same amount, negative 0.001. But you see that there will be a problem. Okay. That initial pressure is still propagating. I haven't done anything about that yet. I will once I look at this situation. That's going to be problematic. You can see that. Okay, let's look at step one. The end of step one, it should be in 3000, state of stress should be 3000 psi. Okay, now we go to step two. The first one should be exactly what was the end of step one, which is 3000. And now let's go and look at the other increments. This stress should go down and eventually should become zero. Okay, got down, smaller, 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 smaller. Now it becomes negative. You see? Negative. It should be zero. Okay, so that first of all clarifies the situation that I cannot make this thing negative. Let's put it back to zero. And I know if I run it, it's going to work. We already know that. But what I'm going to do is I'm going to take the pressure that was propagated from the first step to the second step and see whether it's going to work or not. And you see that actually didn't work in tutorial one, but it will work here. Okay? Because we did different things, as you can see. So let's go back here. If you right click feature manager, that pressure one was over here. This is pressure one. And I go there, right click, remove it from static step two. Gone. Okay. And I'm still sending it back to zero. So let's go ahead and run it and see what happens. It's going to finish in a minute. Okay. Oh, done. Extracting results. So at the end of step one, pressure should be, or stress should be 3000. At the end of step two, it should be zero stress. So let's check it out. Okay, so let's go to step one. The end of it, 3000 psi. We go to step two. Of course, it starts with 3000 and it should gradually reduce to zero. Smaller, 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 and then zero. So no problem. In tutorial 2, I could remove that pressure, stop it from propagating to the step 2, and get good results, correct result. Now, before I stop this thing and go to tutorial 3, I want to point out something that when you remove, notice that what I did, I went to feature manager and I removed that pressure. Let's see what the effect of it is in the tree. Notice that I started with step one, there was a pressure here, okay? And I went to step two and I removed it from step two. It doesn't appear here, okay? Now, of course, that pressure one is still on the very top, but it's only appearing in step one and not in step two because it automatically got propagated, which was fine. And then I said, even if I remove it from that, it'll give you the answer that you expect. All right.